Minimal cost problem. This is a Codeforces problem. Let's discuss it. So the problem statement says that there is a graph of n rows and 10 raised to power 6 plus 2 columns. Column starts at 0 and ends at 10 raised to power 6 plus 1. Rows start at 1 and ends at n. So we have n rows and each row has one obstacle. There are nodes in the graph and we start at 1, 0 node, and we have to find a way and reach our destination, which is at n, 10 raised to power 6 plus 1th column. But this problem is that we cannot pass through an obstacle. So we'll have to find a way to reach our destination without passing through an obstacle. So what we can do is we can displace an obstacle either left or right, or up or down. But while displacing, we have to keep in mind that we do not put them over another obstacle, or we do not kick them out of the graph. So that has to be kept in mind. And each operation of displacing the obstacle either to left or right or up or down costs us something. Like if you move it to left or right, it will cost us V amount. If we move it upward or downward, it will cost us U amount. Now we have to reach our destination such that this cost of moving the obstacle is minimum, and that's why this problem is called minimal cost problem. So here are the inputs. Input first line is going to be n, number of rows, U, the cost of moving it upward and downward, V, the cost of displacing it to left and right, and then there will be an array of n element. First element will point to the position of the first obstacle, that is position of the obstacle in first row. Second element will point to the position of the obstacle in second row. So by position I mean the column number. For example, here the column number should be 2. So second element should be 2. Then there is constraint. Number of rows has to be at least 2 and at the most 100. And this constraint says that we cannot have any obstacle in first 0th column and last column. So these two columns, first and last, are going to be obstacle free zone. So these are free zone. You can freely move through anywhere you want and we can easily reach our destination. So if somehow we find a way to come here, reach this node or any node in this line, we'll simply glide down and reach our destination. So this is very important constraint. Keep this in mind. In fact, this is what made this unsolvable for me. I could not solve this problem just because I didn't know. I had not paid much attention to the constraint. The constraint says that we cannot put there is going to be no obstacle in first and last column, and this solves out a lot of problem. We'll see how. So let's take an example how things work. So what we are going to do is, if you check that there is an obstacle in each row, an obstacle has to be in each row. So we cannot, if we wanted to move through this line, we cannot do it until unless we displace it. And how are we going to displace? We can maybe put it right and then maybe take it upward, and then we'll have a free path. And this entire row is going to be free now because there was only one obstacle in this row and now it's no more in this row. So this entire row is free. And if we now we can easily reach this last column, and this last column is completely free and we'll be able to reach our destination. Okay, cool. Now what we can do, we can also look for some other opening. Like this is similar. We'll again have to move it right and then up, and then we'll have a way. Okay. So what if we look at these two consecutive nodes? So if you see there is a distance of greater than, okay, let me mark it. If this is first column, this is second column, this is third column, and this is fourth column, the distance between these two is 4 minus 1, which is 3. So there is a gap of 3. So you can see that we can easily go through here, and then when we cross this row, an obstacle is already behind us, there is going to be no any other obstacle. We can simply zoom through this entire row and drop down and reach our destination. So we don't need to do anything, we don't need to displace anything if we find two nodes such that the distance between them is greater than 1. If the distance is greater than 1, you will find a way. So this is one of the case that we have to keep in mind. Okay, What if the distance is not greater than 1 but 1? Like in this case, this distance is 1. This is at second column and this is at first column. So 2 minus 1 is 1. Okay, let's do one thing. We'll come here and now we have to get rid of this node or this node. So what we can do, either we can shift it upward or we can shift it rightward, and then this will create a gap. We'll come in front of this obstacle and this entire row is free, and again we can reach our destination safely. So what did we do? We either shifted it upward or downward, whichever seemed less costlier to us, we did it. So whenever the distance is 1, this will always be true. When the distance is 1, we can either shift it upward or rightward. Okay, cool. Now if we have, for 2, I already said that we need at least 2 displacement. Like we have to take an right displacement and an upper displacement or downward displacement or another right displacement, but at least 2 displacements are needed when we have rows, when we have obstacle one above the other, or when the distance between these two are 0. Like this is also at the same column and this is also at the same column, so distance between them is literally 0. So in order to create a gap, in order to create a way, we need at least 2 displacement, and one has to be in right direction, in horizontal direction, and the other can be either upward or again a rightward. This will create a distance. See, so 2 displacements are needed, and out of those 2, one has to be in horizontal displacement. Okay, so there are 3 cases. One, when we find 2 consecutive nodes one above the other, distance is 0. The other, when we find the distance is 1 when the nodes are diagonally, and the other when the nodes are separated at a distance greater than 1. In this case, we can simply glide through it and we don't need to displace it. In this case, we needed at least 1 displacement, either upward or rightward, in order to create a gap. And in this case, we needed at least 1 rightward displacement and 1 either upward or downward displacement. Okay, cool. So now we have 3 cases. When the distance is greater than 1, we simply move through here and we find a gap, and we come here and we reach here. So in this case, the answer is going to be 0, because this is the minimum possible cost that we are going to spend. We found an opening, we came over this obstacle, and we found the entire path to be free, and we dropped down. Okay, now what we can do is, when you look at the second case, when the distance is 1, in this case what we can do is we come here, we put it over here, either put it upward or rightward, and we have a gap, and then we can come here and zoom down and reach a destination. So in this case, we have to pick the minimum of the 2 operation, either take upward or vertical displacement or horizontal displacement, whichever costs less. Okay, the next case is when the distance is 0, when one row is placed above the other. In that case, as we already discussed, we at least need 2 displacement, one towards the right, which is mandatory, and then either to the left, to the right, upward or downward, or to the horizontal displacement. So either a vertical displacement or an horizontal displacement would do, but one has to be an horizontal displacement. So that's why a horizontal displacement V and either of the minimum, or a horizontal displacement or a minimum displacement in this case. So answer has to be this. Now when we come across when we solve this, we are going to look at nodes which has the least effort it takes. Like in this case, it has to be 0, because we found a place where we could easily go. So the minimum of all these will be taken while answering. So this is the solution which the author says. When the distance is 0, the answer has to be, when they are placed one above the other, you have to take a horizontal displacement and then choose between horizontal or vertical. When distance is greater than 1, the answer has to be 0, because you have got an opening and you don't need to displace anything. But if the distance is 1, then either you need to take a horizontal or a vertical displacement, whichever costs less. And we are going to iterate through each row and check, and the answer we are going to have is going to be minimum of all these things. We are going to check between all the consecutive nodes what is the distance, and then accordingly we'll have the minimum possible answer as our answer. The place where we find the opening, or with the least amount of effort we find the opening, that will be our answer. Okay, so let's take a look at this example. So 2 rows, 3 is the cost of upward and downward displacement, 4 is the cost of horizontal displacement. So if we start here, we have to come here, and there is an obstacle over here. What we do, we need to get rid of this obstacle. How can we get rid of, since they are placed one above the other, we have to do at least a right displacement and then choose between right, upward or horizontal displacement. Here upward displacement costs less, so we'll choose an upward displacement. So we come here and we can easily go. So a right for 4 and then an upward displacement plus 3. So the answer comes out to be 7. Next, let's say we have this and these 2 nodes. We come here. Now the distance between consecutive node is 1. So either what we can do, we can either move it upward or we can move it horizontally. What we do is depends on the cost of the operation. Moving it upward costs less, so we move it upward and we have a free zone. We can go there and we'll reach our destination. So the answer is upward 3. Okay, let's code it. So test cases, number of test cases, while t minus 1, answer let it be float inf and and we are going to take the input n comma u comma v, these 3 integer, map integer. Now we are going to take array input, list object. Now for row in range, first row and last row, let's take consecutive distance. Consecutive distance will be array of row minus the previous row minus 1. Okay, if consecutive distance is greater than 1, in this case our answer is going to be 0. If consecutive distance is equal to 1, in this case our answer is going to be minimum of u or v. Whatever is minimum, will take this, but we'll take minimum of the answer. Whatever opening takes lesser effort, we'll pick that out of the whole iteration. So answer minimum of this entire thing. And if consecutive distance is greater than 1, is 0, place 1 over the other, then in that case we have to do 2 displacements. So minimum of answer comma, we have to take a mandatory left or right displacement plus minimum of horizontal or vertical, as discussed earlier. And at last we can simply print our answer. So let's check. So this, copy this input, sample input, and Python try. Okay, so there is a typo. Let's check. What is it? MIN, sorry. Okay, so we have done something wrong, I guess. Okay, so we have to take absolute of the distance. I think now it will work, surely. So this is the output. Bingo. Thank you.